So we have another red day. Day 12. Web timing attacks. If I can't steal their money, I'll steal their joy. Okay, that sounds like a great person. Werewolves Bank had a huge turnover this year and expected a massive profit before the holiday season. They were eager to disclose this news to the town people during the Sakmas celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, the accountants were shocked to see a considerable loss. They observed discrepancies in the account balances. The bank called McSkitty to help investigate these fraudulent transactions. Upon analyzing the bank's website's traditional logs, McSkitty found some interesting transactions. Few users, including the mayor's team, initiated multiple transactions from Werewolf's reserve accounts at once. Surprisingly, all these transactions succeeded despite exceeding the user's current balance. Glitch was already aware of the critical vulnerability, allowing these fraudulent transactions that Mayor Malware and his alliance exploited. So, Werewolves Bank. Oh, there's stuff coming out of there. Learning objectives. Understand the concept of race condition of vulnerabilities. Identify the gaps introduced by HTTP 2. Exploit race conditions in a controlled environment. Learn how to fix the race. Connecting to the machine. And today we have no split screen. So we need our Kali machine, hopefully, not the tech bugs, and this machine. So click on the green start machine button below and we'll get an IP soon. So we will have a website. Let's just wait with copying that and continue reading. Sorry. Web timing and race conditions. Conventional web applications are relatively easy to understand, identify, and exploit. If there is an issue in the code of a web application, we can force a web application to perform an unintended action by sending specific inputs. These are easy to understand because there's usually a direct relationship between the input and output. We get bad output when we set bad data, indicating a vulnerability. But what if we can find vulnerabilities using only good data? What if it isn't about the data, but how we send it? This is the web timing and race conditions attack come into play. Let's dive into this crazy world and often hidden attack surface. So we saw the IP address popping into existence over here, so let's actually copy this. We need the VPN there, so I'll just hop over here. And let's open the browser. And I think I turned off burp, so this should work. So we have a login account number and password. This is what the site looks like that they gave us. In its simplest form, a web timing attack means we can glean information from a web application by reviewing how long it takes to process our request. By making tiny changes to what we send and how we send it, and observing the response time. We can access information we are not authorized to have. Race conditions are a subset of web timing attacks that are even more special. With a race condition attack, we are no longer simply looking to gain access to information, but can use the web application to perform unintended actions on our behalf. Web timing vulnerabilities can be incredibly subtle. Based on the following research, so there's a link here, response time differences ranging from 1300 milliseconds and 5 nanoseconds have been used to stage attacks. That's not a big difference, 5 nanoseconds. Because of their subtle nature, they can also be hard to detect and often require a wide range of testing techniques. However, with the increase of adoption of HTTP2, they have become a bit easier to find and exploit. And actually, I heard Tiberius talk about this kind of recently. So, the Portswigger. Yeah, so we can look at this later. So, the rise of HTTP2. HTTP2 was created as a major update for HTTP, the protocol used for web applications. While most web applications still use HTTP 1.1, there has been a steady increase of that in the adoption of HTTP2, as it is faster, better for web performance, and several features that elevate the limitations of HTTP 1.1. However, if implemented incorrectly, some of these new features can be exploited by threat actors using new techniques. The key difference in web timing attacks between HTTP 1.1 and HTTP 2 is that HTTP 2 supports a feature called single packet multi-requests. Network latency, the amount of time it takes for a request to reach the web server, made it difficult to identify web timing issues. It was hard to know whether the time difference was due to a web timing vulnerability or simply a network latency difference. However, with single packet multi-requests, we can stack multiple requests in the same TCP packet, eliminating network latency from the equation. Meaning time differences can be attributed to different processing times for the requests. This is explained more in the animation below, so let's look at this. So we see the difference in time there, and I'm thinking we'll see HTTP 1.1 too. Here we have HTTP 1.1, one is sent, one back, another sent, another back. So they didn't have the clocks on there. Maybe it was just too quick for us to be able to read. So, obvious, right? They already explained it in text. Since we send them in the same request, there will be no time difference there. I mean, the network delay won't matter. With network latency a thing of the past, only server latency remains, making it significantly easier to detect timing issues and exploit them to discover sensitive information. Typical timing attacks. Timing attacks can often be divided into two main categories. Information disclosures, leveraging the differences in response delays. A threat actor can uncover information they should not have access to. For example, timing differences can be used to enumerate the usernames of an application, making it easier to stage a password guessing attack to gain access to accounts. Race conditions. Race conditions are similar to business logic flaws that a threat actor can use, can cause the application to perform unintended actions. However, the issue's root cause is how a web application processes requests. making it possible to cause the race condition. For example, if we send the same coupon request several times simultaneously, it will be responded to. It will be possible to apply it more than once. For the rest of this task, we will focus on race conditions. We will take a look at the time of check to time of use, TOCTO. So time of check to time of use, flaw. Let's use an example to explain this. So data there, data there, data there, data there. Time, request 1, submit discount code, code already used. Sumner sent it to it at the same time. And the discount is applied for both. Instead of it already being seen that, well, this one happens before this one instead of at the same time. The animations. Let's hop one bit more down so we can see it. When the user submits their coupon code, in the actual code of the web application, at some point we perform a check that the coupon is valid and hasn't been used before. We apply the discount, and only then do we update the coupon code to indicate that it has already been used. In this example, between we check if our coupon is valid and our update of the coupon is being used. There's a couple of milliseconds where we apply it. While this might seem small, if a threat actor can send 2 requests close enough together in time, it might happen that before the coupon is updated in request 1, it has already been checked in request 2, meaning that both requests will apply the coupon. Winning the race. Now that you understand basic concepts related to race conditions, let's explore how the vulnerability occurs in real-world scenario. For this, we will take the example of the Werewolf banking application hosted on, our thing we went into. This application allows users to log in and transfer funds between accounts. Intercepting the request. Before we start intercepting requests, we need to configure the environment so that as a pen tester, all web traffic from our browser is routed through Burp Suite. I'll just click it because it's slow start. There. This allows us to see and manipulate the requests as we browse. We will use Burp Suite, a powerful web vulnerability scanner, to intercept and modify requests for this exploitation. You can access Burp Suite in the attack box, and we're not using the attack box. Once you click the icon, Burp Suite will open an introductory screen. So, and then you get this screen. And once Burp is started, you will see its main interface with tabs as a proxy, intruder, repeater, and others. Though ours is not bright light mode. In Burp Suite, click the Settings tab at the top right. You will see Burp's browser option available under the Tools. Allow Burp's browser. Well, this is for the. We're not using that either. We're using Firefox. So, if you do this, you can read it. After allowing the browser to run without the sandbox, you should be able to start the browser. So, Proxy Intercept tab.
Yeah, you burp that sweet. Burp it like a baby.
Hi, H. Welcome in. So, what's some time since I saw you here, though? So, we have Burp started, but we're not using Burp's internal browser. We're using this instead. Hi, Panda.
Gutenberg Morgan Horgan. translated from German.
That's funny. Oh my god. So, let's go back. Once you browse the URL, all the requests are intercepted, and you can be seen in the HTTP history tab. So, oh, sorry. As a penetration tester, one key step in identifying race condition is to validate functions involving multiple transactions or operations that interact with shared resources, such as transferring funds between accounts, reading and writing to a database,
I'm gonna bail.
updating balances.
Say hi.
Okay.
Don't want any spoilers.
You're gonna do it all? Have you started on Age of... No, it's called Age, not Advent. You're confusing me. Age of Music, Advent of Cyber. So it became Age of Cyber. We're in the Age of Cyber. Yeah. Okay, so though it's not like an advanced one, right? You can stay if you want to, but I understand it totally. I wouldn't want it spoiled. So have a great day, and thanks for saying hi. So let's hop over here and click burp, right? So we have burp. Now we have login information. This is what I was waiting for, right? We have the login credentials here. For this example, we will log into Wearable Banking application using the credentials. Once logged in, you will see the following dashboard that will contain the following two primary functions. So let's just check it out here. So, account number is 110. I wish mine was as simple. So, tester. So, we're now in the bank. We have 1,000. So, we're going to send probably a request to get more than that, right? From building a HTTP2. So that's what we saw. Yeah, you will see two functionalities: logout, which probably does not involve simultaneous tasks. Next is fund transfer, which includes deducting funds from the account and adding them to another account. As a pen tester, this could be an opportunity for attack. We will see in detail how, as a pen tester, you can exploit the vulnerability. Verifying the fund transfer functionality. We will browse the bank application and perform a sample transaction inside the browser. This will generate multiple GET and POST requests, and whatever request we make will be passing through Burp Suite. As shown in the figure, our current balance is $1,000. We will send 500 to another bank account with a number 111. While doing that, all our requests will be captured by Burp Suite. Click on the transfer button and you will see the following message indicating that the amount has been transferred. So let's send something. So I guess we do exactly what they do because we're supposed to, right? So we send half of it to 111, and I'm kind of thinking that we could send back and forth and we just increase the money we have, right? So what if that had worked for reals? And you would be that kind of person that would do such a thing, right? Success, transaction ID. So, before we hop back, let's just look at this in Burp, right? Because I'm curious. So we want to see the history. So first, let's actually drag this a bit, right? So we want to see the ones over here. My god. I don't know. I won't like the time sorted on time. I wanted to see the time too, though. There, now you can see the time. And now this doesn't work because so if I move this, it moves both. Okay. Anyway, let's look at the first one. So this is when we just go into the dashboard, I'm assuming. And cookie. So now this is the successful one. So we started here. I thought it was backwards first because I clicked, but maybe it was actually. Here's a login. And it's redirecting us. And so display flash messages. Target account. Font family Ubuntu. And then we're sending account number, amount, and we're redirected again to the dashboard. So post to login, post to transfer, and then we get to the dashboard afterwards. Okay. And here we have the success, the transaction ID thingy. So, now let's review the phone transfer HTTP post request logged in Burp Suite. This HTTP history option. Yes, so we did this. They're just telling us how to get there. So they wanted to send it to the repeater, of course. So let's hop over and send this transfer. This must be the one they want us to send. Where we actually do it. Send this to the repeater so we can send this again. We don't want to transfer 500 now though, right? Wouldn't have any money left. By the way, let's actually check the page. I didn't look at it thoroughly enough, apparently. Yeah, so it says balance 500 up here now. So if we were to do another test, we were to have no money left to continue this thing. And now send to repeater, navigate to the repeater tab. We will find the post request that needs to be triggered multiple times. We can change the amount number from account number from 111 and the amount from 500 to any other value. Okay. So, learn more by why this happened. Why did this happen? This never happened to me before. That's interesting. Cost saving measure implemented. Should not be frequent. Yeah, so it never happened to me. So I'm totally okay with that. But it's a bit annoying when you're streaming, right? So, okay. So let's click the start machine button again. So now we have all the money left though, but we have to redo stuff. And we have to wait. And it's not like I haven't paid them a lot of money actually, because I'm subscribing. take the opportunity to just scroll through the page. So minus 4,500 there. So I don't think this will take much time, but this is quite annoying. I'm scrolling up to the little tiny thing here. 10, 9, 8, 7, 6. IP. So we have the new IP. Let's up over here. Let's redo it all. So I could change the IP, right, in the request, but we might want to have it here too. So the dashboard will need to log in, and the credentials were, yeah, it's easiest just to redo it. Scrolling down there, so we have 110 tester. And then we have we're doing our test transfer here of, let's scroll down again, 111,500. And we send this. And we get our confirmation that the transfer was correct. And we close this one and hop back to the proxy history. And then we get the new transfer, and we forward this one instead to repeater. So now we can delete that one without it being sad. So this is now our new one. So send it to repeater. Now navigate to repeater tab, find the post request that needs to be triggered multiple times. We can change the account number from 111, the amount value from 500, to any other value in the request as well, as shown below. So let's see. And here it is saying, oh, they're just showing it, they haven't changed it. Okay. Place the mouse cursor inside the request inside the repeater tab in burpsuite, and press Ctrl R to duplicate this tab. Press Ctrl R 10 times to have 10 duplicate requests ready for testing. So we're going to do 10 of them. Okay. So we do it. Let's do it. I'm glad I deleted the other one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I did actually click it 10 times now, so yeah, let's delete one. Now we have 10. Now that we have 10 requests ready, we want to send them simultaneously. Well, the option is to manually click the send button on each tab individually. We aim to send them all in parallel. To do this, click the plus icon next to the request. 10. Well, it's 11 for us. And select Create Group tab. This will allow us to group all the requests together for easier management and execution in parallel. And this taught me something new about burp. I didn't know this. So, next to the 10, well, 11, because it died on us, there should be a plus. So, is this the one? Create tab group. And then we just select all of them. So, I've seen this done, actually, when I'm looking at it. I've just had no use for it yet. So, let's create this. So now we have a group. So, interesting. New possibilities. After clicking the Create tab group, a dialog box will appear for you to name the group and select the button. Select request to include, for example, funds. They're naming it something. Now, we are ready to launch multiple copies of our HTTP post requests simultaneously to exploit the race condition vulnerability. Select Send Group in parallel. Last byte sync in the drop-down next to the Send button. Once selected, the Send button will change to Send Group Parallel. Click this button to send all duplicated requests in our tab group at the same time, as shown below. So, we click here, and we select Send in Parallel, and then we click Send Group. So, we can follow redirection here too, but let's listen to what they want us to do. So we can see our account balance. Once all the requests have been sent, navigate to the tester account in the browser and check the current balance. You will notice that the tester balance is negative because we successfully transferred more funds that were available in the account, exploiting the race condition vulnerability. By duplicating 10 requests and sending them in parallel, we're instructing the system to make 10 simultaneous requests, each deducting 500 from the tester account and sending it to account 111. It is correctly in a correctly implemented system. The application should have processed the first request, looked at the database, and locked the database. Process the remaining requests individually. However, due to the race condition, the application handles these requests abruptly, resulting in a negative balance in the tester account and an inflated balance on account 111. Verifying through source code. Suppose you're a penetration tester with access to the application's source code, as in white box testing scenario. Let's look at it first, right? So we didn't look. So let's look at the browser here. And let's just F5 this page. So now we have minus 4,500. So it worked for us too, as it should. Or shouldn't. By analyzing our code, we can pinpoint areas where multiple database operations are performed without proper transaction handling. Below is the Python code that handles the fund transfer. If user balance amount, update user balance was. So yeah, it does both there. In the bow code, if user balance is more than or equal to amount, the application first updates the recipient's balance with the command update user set balance equals balance plus, where account number equals, followed by a commit. Then it updates the sender's balance using update user set balance where account number equals, and commits again. Since these updates are committed separately and not a part of a single atomic transaction, there is no locking or proper synchronization between these operations. This lock-off transaction or locking mechanisms makes the code vulnerable, lack of it, vulnerable to race conditions. At current requests could interfere with the balance updates. Yeah. Time for some action. Now that you understand the vulnerability, can you assist Glitch in validating it using the account number 101 and password Glitch? Attempt to exploit the vulnerability by transferring over 2,000 from his account to account number 111. Okay, so let's just do it. So we have logout, And I'm actually going to hop to burp, and since we had the messy history here, let's just clear the history. So we have a fresh and empty thing there. So we're going into account number 101 and glitch. Let's see. Oh my, I did click the logout, didn't I? I assumed we were in this already. Maybe I didn't click. So glitch is the password. So we're supposed to transfer 2,000 from his account using the vulnerability. Now he has 2,000, so it feels like. One thing I want to do first is to see if they... Yeah. So there's the flag that we're getting here. That's what I wanted to see. So first we send like... let's do 500 then, right? And amount... Okay, 111. Here, 500. So then we have transferred 500. Then we have 1,500 left. It doesn't say what amount they want left on the account, right? So we could have transferred 1 instead. And then we hop over to burp, and we look at the transfer. We have oh, I transferred to the wrong account number. Then we go repeater, and we send it instead to 111 and 500. So the problem is it has 2,000, and it still calculates the correct sum, so it is not correct. So let's assume that we want this to be copied 4 times, meaning 3 times. So let's make 3 copies and plus these together in a group. 13, 14, 15, and 16, meaning 500 times 4 there. So I don't think they thought through this. I don't know why they selected the same amount they already had on the count. I mean, it wouldn't be a minus. So now we're actually going to, since we used the wrong account first, you know, it's easier. Because we have to do this with 2,000. So, again, we do this, and we do parallel. We have these 4 in the group. They're each doing the same thing. Account number 111, confirming that we're asked to do to account 111, $2,000. So this will be that. So we just send it, and then we look at the account, and the balance is 0. So didn't the first one go through then? Anyway, the thing I'm thinking about, you know, it should have been minus, since we sent 4 of these, it should have been minus 500 if the first one went through. Now I'm thinking it didn't. So let's just send them again and see what it said. I should have looked between, right? Let's follow the redirection for this one. So it should say like you don't have enough money on your account. Welcome glitch, balance 0, transfer money. So it didn't do anything. Yeah, so that's annoying because we'll have to reset it, right? So terminate. And we'll read the rest while it's starting again. This would have been less terrible if it's already hadn't required another restart, right? So, it's so much, looks like a lot of text, but it's really not, because it's images, right? So, attempt to exploit the vulnerability by transferring 2000 from his account to the account number 111. Fixing the race. The developer did not properly handle concurrent requests in the bank's application, leading to a race condition vulnerability during fund transfers. When multiple requests were sent in parallel, each detecting transferring funds, the application processed them simultaneously, without ensuring proper synchronization. This resulted in inconsistent account balances, such as negative balance in the sender's account and excess funds in the recipient's account. Here are some of the preventive measures to fix the race. Use automatic transactions. The developer could have implemented automatic database transaction to ensure that all steps of a fund transfer, deducting and crediting balances, are performed as a single unit. This would ensure that either all steps of the transaction succeed or none do, preventing partial updates that could lead to an inconsistent state. Implement mutex locks. By using mutex locks, the developer could have ensured that only one thread accesses a shared resource, such as the account balance at a time. This would prevent multiple requests from interfering with each other during concurrent transactions. Apply rate limits. The developer could have implemented rate locking on critical functions like fund transfer and withdrawals. This would limit the number of requests processed within a specific time frame, reducing the risk of abuse through repeated requests. So, the race thingy is I'm thinking of processor instructions instead here, but that's what it all boils down to, right? So you need to have an instruction that sets a value and reads it at the same time, and there is, right? So it needs to check first. This, I guess. So, what is the flag value after transferring the 2000? So we need to do this. If you enjoy this, go to race conditions, where balances shift and numbers soars. Look for an entry in open door. Yeah, so we keep getting these hints, right? We got one yesterday too, I think. No, it was not yesterday. It was... Oh my gosh. So they're telling us look more at this one, right? Was it this one, maybe? I don't know which one it was. One of them had a question, and I wrote it down in notes. Yeah, it's not that one. Anyway. So this, we have a new IP. So, let's log in. Let's remember the login creds, of course. And what we're supposed to do. So let's go back here. This is where we did it. Here. So this is what we're supposed to log in with. Let's close all of these, right? I'm almost restarting Burp because this is a lot of clicks. A lot of clicks. click, 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 and clearing here, just to have a clear history, right? And then we go back here and we put a new IP. We can do that too. So, and we start with logging in, carefully looking at the numbers this time, since I wrote something else than I should. So 101. And the password, glitch. There. Then I'm assuming, so we have 2000, we can just transfer 2000. Attempt to exploit the vulnerability by transferring over 2000. I didn't read I just checked the fat text. So now we know. Now we can transfer how much we want. It doesn't have to be 2000. Because that was odd, right? So we're supposed to do it 211, right? So let's repeat the same, because that might be the exact thing they want, right? You never know what the try-hack means. So let's do 500, because that's what we did. Let's transfer. And this one I had the correct account number. So let's go here and look at the transfer. With the correct numbers, it's redirecting, but we just want to send this to repeater. But let's go back and check the account. So F5 this. Now we've lost 500 there, as we're supposed to. And it's supposed to have gone into the right account. So here we have it in the repeater. So let's duplicate it, so we have 10 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're keeping the same requests. And I did it 10 times again. I'm like, why? I will see. I'll do 9 times in this. I thought it, you know. I didn't do it though. So clicking all the tabs. There, we could put a name to it. And then we're going to select to send these in parallel. And then we're going to send them in parallel. And hope that it works this time. So we go back here. And we update. And we get a flag. So, there. Won the race, and we got minus 3,500. You never know if they want the exact same thing, right? So let's open this room. I don't think I will click finished on this one, because I want it to be there still. Where balances shift and numbers soar, look for an entry and open door. Yeah. So we're supposed to find something else here. But not right now.